So everyone, for this video, we'll be discussing the February-March 2025 Pure Mathematics 3, Paper 3-2. So let's start with question number 1. Okay, so they want us to solve this equation, and then our answer should be correct to 4 decimal places. Alright, okay, so of course, to solve the equation, we want to find the value for x, right? So first of all, we need to try and get rid of everything from the x. Okay, so first step, I will try to move the 3 over, become -3. Alright, then after that, for the ln, now I want to get rid of the for the ln because the -2x, right, e power -2x is inside the ln. So if I want to get rid of the ln, I have to bring it over. So what is the base of the ln? Ln basically means log e. So if you want to bring the ln over, it will become base e with the power -3. Okay, so you need to know ln means log base e. Okay, right. Then now next you have to keep only the x on one side, then all the other variable on all the other number or constant on the other side. Okay, then after that, if I want to make the -2x down become a number, I have to take ln both sides. If you want to take log both sides also can, but for me I prefer to take ln. It is because of ln e is equals to 1. Okay, so I'm having ln 1 minus e power -3. Alright, so just a quick recall, yeah. When you are trying to take ln both sides, then firstly you need to know that when you're having ln x power n, it can be written as n then ln x. So that's the reason why I have -2x in front of ln e. Okay, so secondly, you need to know that ln e basically is equals to log base e with the e. So when you're having the base and also the number is the same, then you will always have a 1. Therefore, for the next step is you're having -2x and ln e is equals to 1, right? Like what I told you here. Okay, so to get the x, I need to bring the -2 over, it will become -½ then ln 1 minus e power -3. So please try to press calculator and see what is the answer that do you get. Alright, so they are requesting the answer into 4 decimal places. So by pressing calculator, by right, if you didn't do any careless mistake, it should be 0.0255. So this is the 4 decimal places answer. Alright, yeah, so this is how we solve question. Alright, so question number 2. We are given the equation of the curve, which is something like this. And then you can see very clearly that this is an implicit function where x and y cannot be separated clearly to each side. Alright, so we call it as implicit function. Find the gradient of the curve at the point where x equals to 0. Okay, gradient of the curve. So what's the meaning for gradient of the curve? So you should know that gradient of the curve means dy dx. So we want to know what's the value for dy dx when x is equals to 0. That means at the point of x equals to 0. So first of all, of course, we need to find out dy dx first. And because we are having this, which is the implicit function, therefore, when you want to apply differentiation, you have to apply implicit differentiation. Okay, so implicit differentiation means that we just differentiate like normal equation, just that when you involve any differentiation with the y, you have to put the dy dx at the back. Alright, so let's have a look here. Okay, so for the first term, we are having xy squared. So xy squared basically is the product of two functions. So you're having the first bracket, which is a x, the second bracket, which is a y. So to differentiate the product of a function, you need to actually apply product rule for differentiation, right? Okay, so let us start. So I assume x is the first bracket, yeah, y is the second bracket. So product rule means that you copy the first bracket, which is x, then you differentiate the second bracket, y squared. Differentiate y squared, you have 2y. But because this one involves the differentiation of y, right? So you have to put a dy dx, right? Then plus. So just now you copy the first bracket, differentiate the second. Now you copy the second bracket, differentiate the first. So copy the second bracket, you'll be having y squared. Differentiate the x, you have a 1. And because you differentiate something with the x, right? So by right, there is a dx at the back. But because dx over dx is a 1, so most of the time we actually didn't write it out. So you can see that when we try to differentiate something with the y, right? So it will be, we need to put in the dy dx at the back. When you differentiate something at with respect to x, then you have to put dx. Just that dx over dx is a 1. So most of the time we didn't write out. Okay, so I hope that you understand now why I didn't write out here. Okay, then after that, for the next term, I'm having ln. How are you going to differentiate the ln with a bracket? So the general step is, when I want to differentiate the ln with a bracket, I will bring the bracket down, become denominator. So I'm having x plus 2y. Then after that, I have to differentiate the thing inside the bracket. So when you want to differentiate the x, you'll get a 1 with dx. So I didn't write it out. And then when you want to differentiate the 2y, you'll get 2. And then because this is something related to y, right? So I will write in dy dx here. And equals to, when you differentiate a constant one, you will get a 0. Okay, so please don't forget, yeah, when you differentiate a constant value, you'll always get a 0, yeah. I think common mistake that students do here is they always copy back the 1 and end up the answer is wrong. So make sure that you take note on this. Okay, all right, then after that, if I want to get the value for dy dx, when x equals to 0, so let's have a look for our equation here. We can substitute our x equals to 0. So when I substitute x equals to 0, this whole term becomes 0 lah. But at the same time also, you will see that I actually need the value for the y. So that I can substitute in the value of y inside, the value of x and y inside, then eventually only I can get the value for dy dx. So how can I find out the value for the y? So of course, you have to use the original equation to find it out. When x equals to 0, what happened to your original equation? So let's have a look here. Substitute x equals to 0. So first term here, you'll get a 0. The second term here, you're having ln 0 plus 2y, so which is a 2y, and it is equals to 1. So again, you have to use a little bit of the properties of exponential and also the log function. Ln is base e, so bring it over, become e power 1. Okay, then after that, you're having y is equals to half e power 1. Right, so now these two values are very important. X equals to 0. When x equals to 0, your y is actually equals to e power 1 over 2. Okay, so now I want to substitute it back into my differentiation just now and get the value for dy dx. When x equals to 0, you substitute it into this particular term. This term becomes 0, right? Okay, then now I'm having the second term as y squared. So when you're having the second term as y squared, what do you have here? You're having 1 over 2 e power 1, then square. Okay, then plus. How about the next term? So the next term here, x is a 0, so you don't write anything, but you're having 2. Then y is half e power 1. Then multiply with 1 plus, then 2 dy dx. And it is equals to 0. Okay, so this particular step is we try to substitute all the value for x equals to 0 and also y equals to e power 1 over 2 into my differentiation equation just now. So the differentiation technique that we call it just now, right, we did just now is actually the implicit differentiation, right? Okay, so you can see that now I'm getting this equation here. I just need to slowly rephrase my equation and simplify them. Eventually, I will get the value for dy dx. Okay, so I try to write out first. So I'm having 1 over 4 e power 2. Because for the 2 here, you have to square the number. You also have to square the e, right? E power 1. Then for the second term here, you can see that half and half can be cancelled off. 2 and a half can be cancelled off. So you're having 1 over e 1. Then you multiply it with 1 plus 2 dy dx. It is equals to 0. Slowly move the 1 over 4 e power 2 to the other side. 1 over 4 e power 2. Then I want to get rid of the e power 1 at the denominator, right? So I multiply it, or I bring it to the right hand side, become multiply. And e power 1 multiply with e squared, you're having e power 3, right? Okay, so I move everything slowly to keep only the dy dx on the left. So I'm having negative 1 over 4 e power 3, then minus 1. And last step, if I want to get the dy dx, so I will need to have negative 1 over 4. Oh, sorry, I bring the 2 over, right? So I have to take the 1 over 4 divided by 2. So I'm having 1 over 8 e power 3, then minus 1 over 2. Alright, so let's have a look for this question again. What is the value that they asked us? So they said the gradient of the curve, but they didn't fix whether what kind of pattern do they want for the final answer. Do they want the exact value or do they want the decimal number? So if you want to keep your answer in exact value, so this will be the answer for exact value. Alright, so if let's say you found that, okay, you want to try to keep it to 3 significant figure, then you can just try to press calculator. By right, you should be getting this one, negative 3.01. If let's say your answer is into 3 significant figure. Okay, so this is actually how we get the value for dy dx. Okay, so this is how we solve question number. So now we are at question number 3. We are given a diagram, and let's see what they want us to do. So they said the shaded region at the Argand diagram shows point representing the complex number z defined by two inequality. So the shaded region is bounded by a circle and also a line parallel to the real axis. The boundaries of the region are included in the shaded region. So part A, they want us to find two inequalities in terms of z define the shaded region. Okay, so I think it is quite obvious. It is actually bounded by a circle and also a horizontal line. So let's talk about the circle first, yeah. So just to recall back, yeah. For the circle in the complex number form, the general form is z minus x plus yi modulus that equals to the r, where you actually need to know that the x plus yi is the center, xy is the center, and also the r is the radius. So let's have a look for this circle that they draw. Where is the center of the circle? So I think it's quite obvious this is the center. So for this particular center, the coordinate is actually -2 and also 1, right? So when you want to write into the complex number form, it should be -2 plus 1i. So this is your center in complex number form. Okay, and then how about the radius? So have a look for radius. So from center to the circumference, to the edge of the circumference, you can see that it involves 3 boxes, which is 3 units. So your radius should be equals to 3. So if I want to compile everything here into the answer, into a complex number form for z, so it should be z minus the center, which is -2 plus I modulus, then it should be equals to r, which is a 3. But please take note that if it is equals to 3, right, that means the z, the complex number should be on the line of the circle or on the circumference of the circle. But if you have a look for our diagram here, they actually shape the area inside the circle. So that means for the complex number z that fulfill this part is actually smaller or equals to the 3. Okay, but actually when they say smaller or equals to 3 means the whole circle. Okay, so the first inequality from the diagram is you are having z minus the complex number smaller or equals to 3. That means it is the region that denotes the whole circle inside the circle. Okay, so some will prefer to multiply the negative in the bracket become +2 minus I. Smaller equals to 3. Also can, so up to you which one you want to write. So this is the first inequality that we have. Alright, then how about the second inequality? So the area, besides bounded by the circle, it is also bounded by this line. So how can I label this line? Yeah? So this line is a horizontal line, and basically it is having the equation y equals to -1. So when y equals to -1, right? So what is the y in our complex number? If let's say my complex number z is equals to x plus yi, so the y means that the imaginary part of a complex number, right? So we usually we'll write the imaginary part of the z. Alright, so you can write the imaginary part of the z. And you can see that for this line, the area covered is actually below the line. So below the line means smaller and equals to -1. Okay, so if we combine the two inequality just now, one region is bounded by the circle and another region is bounded by the line below the line of -1. So the intersection point, the intersection area for these two inequality will be exactly what they show us in the diagram. Alright, so there's no specific steps for you to follow lah. So you have to know in general what is the complex number formula, the locus formula in the complex number form for a circle, and also how to write out y equals to -1, the equation in terms of the complex number. Alright, so these two will be the answer for part A. Okay, so let's have a look for part B. Right, so for part B, they said find the greatest value of modulus z for the points in this region. Greatest value, modulus z. So what is the meaning for modulus z? Okay, so again, modulus z, basically, I can write it become the modulus z minus 0 plus 0i. Okay, so what is the meaning for this equation, or sorry, this expression? So modulus means distance or the length. Okay, so modulus means distance or the length, yeah? Okay, so z minus 0 by 0 plus 0i, actually it means that it is between the point z and the point 0, 0. Okay, so you need to understand what is the meaning for the modulus z first. So the modulus z means modulus z minus 0 plus 0i, which means that the distance or the length between the point z and also 0, 0. Okay, so what's the meaning for point z? Point z means that it can be any point in our shaded area. So the z can be here, the z can be here, or the z can be anywhere as long as it is in the shaded area. Then 0, 0 is this one. This is 0, 0. Okay, so distance between z and 0, 0 means that, okay, let's say this is my point of z. So the modulus z from 0, 0 is this length. Okay, so if let's say my z is here, then the modulus z and 0, 0 is this one. So that's the meaning. Okay, so z can be any any point in the shaded region. Okay, so for this question, what are they asking? They're asking for the greatest value. So greatest value means that the furthest z. So the furthest z to me, I think is this. This is the point that I want to find. Okay, so this is the longest distance I can have for the z with the 0, 0. Okay, but now I cannot get the coordinate of the z. If I want to know the distance, I need to know the coordinate of the z. But too bad now I cannot get the coordinate of the z because of, you can see that the z is not on the box or whatsoever, right? Or it's not on the intersection of any axis or any boxes. Okay, so I can't actually get the value, the coordinate of the z. So I have to think a way to figure it out. Okay, so for this one, right, there's no fixed method or fixed formula for you to use it. So I have to try to observe and see what is a more suitable method for you to solve it. Okay, so if let's say I want to find this particular z, right? So some students might think of, oh, can I use this triangle to figure out the length of hypotenuse or not? So you know that this is actually 1 unit, right? But you don't know what is the base. So what is the horizontal length or the base, the base length for the triangle? So if you have only the height but you don't have the base, definitely you cannot find the hypotenuse, right? Yeah, so is there any other method that we can use? Yeah, so you have to try to think about it by yourself. And if let's say I try to figure out this one, I know that z is the intersection point for y equals to -1 and also the circle, right? So we actually know how to find out the intersection point between a circle and the line. Okay, so maybe you can try out this one. So let's say the equation of the line is y equals to -1. So can you try to write out the equation of circle in Cartesian form? So just now we know that our center is -2, right? So in Cartesian form, it will become x plus 2 squared. Then plus, what is the center? Y coordinate of the center? It is 1. So when you want to put it into the Cartesian form, it will become y minus 1 square. That equals to r square, right? So the r is the radius. So you're having radius square. So if I know how to put my circle equation in the Cartesian form, but not in the complex number form, and also I get a line equation in also the Cartesian form or the equation form, then I can solve these two equations simultaneously to get the coordinate of the z, because I know that z particularly is the intersection point between the horizontal line and the circle, right? Okay, so I try to solve this. So I will substitute 2 into 1. This is equation number 1. This is equation number 2. So substitute 2 into 1. So I write my solution here so that you can see clearer. Sub 2 into 1. So what do I have? So I'm having x plus 2 square. Then y is negative 1. So you're having negative 2 square equals to 9. And x plus 2 square equals to 9 minus 4. You get a 5. So x plus 2, you'll get plus minus square root 5. And x equals to negative 2 plus minus square root 5. So from here, you actually can see that there are two intersection points between the line and the circle, right? So this is the first one, and this is the second one. And we are interested to look for this one. Okay, the blue arrow one. So what's the x coordinate now? Do you think should it be negative 2 minus square root 5 or negative 2 plus square root 5? So I think it's quite obvious, right? This point, this one, here, okay, by right, the coordinate should be negative 2 plus square root 5. So this one I think is very obvious, negative 2 minus square root 5. Okay, alright. So you successfully get the coordinate of the z that I want. So the z is having the coordinate of negative 2 minus square root 5 and also negative 1. Alright, so I want to find the distance between z and also 0, 0 because I believe that this is the longest distance, the greatest distance between z and the origin. So how to find the modulus z? So you use these 2 points, like the coordinate of these 2 points and find the distance. So it will be x minus x1 square. So negative 2 minus square root 5 square minus 0 square, okay? Then plus y1 minus y2, then square. Okay? Then after that, you try to expand everything and simplify slowly. By right, you should be able to get 10 plus 4 sub 5. If you expand everything slowly, simplify everything slowly, inside you should have 10 plus 4 square root 5. Then again, for this question, did they ask anything about the pattern of the answer? They only say find the greatest value, right? But not find the greatest exact value. So if I get this one, I don't like to have square root inside another square root. So for me, I will change it become answer 3 significant figure. It should be 4.35. Yeah, so basically this is how we solve question number 3. So just make sure that you are aware, yeah, when they want you to solve maybe for greatest modulus z or the shortest modulus z or whatsoever, there's no fixed method or concept or formula for you to apply. We always try to think about some general knowledge that we know. As example, like the circle equation, or maybe the triangle ratio for trigo, all right? So you have to apply some common sense and also some general knowledge for maths, okay, to find out the answer that you want. All right, so this is how we solve question number 3. All right, so now we are at question number 4. Okay, by expressing the equation of this one as a quadratic equation in terms of tangent x, solve the equation. All right, so we are having this equation here. So if you try to have a look, right, we are having a compound angle for tangent, which is tangent x minus 60, and also the cotangent x. For cotangent x, if you want to change it become tangent x, it is not a big problem, right? Okay, then how about for this one, tangent x minus 60? By right, you cannot just expand your tangent x minus 60 become tangent x minus tangent 60, yeah, it is wrong. So you have to use the double angle formula for tangent. I don't know whether it's here, remember or not, that we have this formula. Tangent A minus B can be written as tangent A minus tangent B, then divided by 1 plus tangent A tangent B. Right, so this is basically the formula that we should use. And if you can't remember the formula, of course, it is provided in the formula booklet as well. So you can have a look from MF19. Okay, so this is what I'm going to use that to apply it at the tangent x minus 60. So the x here will be the A, and also the 60 here will be the B. All right, so let us start. Okay, so we are having this on the left. And now I want to apply the double angle formula on my tangent x minus 60. So I'm having tangent x minus tangent 60 because I'm having tangent A minus tangent B, right, according to the formula. Then divided by 1 plus tangent A and tangent B. Okay, then after that, for 2 over cotangent x, you can write become 2 over tangent x. So you can see that for my equation now, right, I'm one step closer to the answer because they say our final answer is in terms of all the tangent x. So you can see I'm having all the tangent x here without any other trigo. Okay, all right. But before that, to continue, I need to know what's the value for tangent 60. All right, so if you want, you can press calculator for the value of tangent 60. By right, you should get the answer, which is square root 3. Okay, then divided by 1 plus square root 3 tangent x equals to 2 over tangent x. Alright, then after that, I want to get rid of the denominator, so I multiply the denominator to the other side on top. So I'm having tangent square x minus square root 3 tangent x equals to 2 plus 2 square root 3 tangent x. Okay, so now after get rid of the denominator, it becomes much more, how to say, I would say that it looks much more simple. Then after that, we need to rephrase our equation into a quadratic equation. So to get a quadratic equation, basically the style is already out. The quadratic pattern is already out because you're having a tangent square here. Alright, so if I try to move everything to one side, I'm having tangent square x. Negative 1 sec 3 tangent x, then minus 2. This one you bring it over, become minus 2, right? So you're having negative 3 sec 3 tangent x. Okay, minus 2 equals to 0. So you successfully get a quadratic equation in tangent x. Okay, alright, then after that, they want you to solve this equation. So to solve the equation, we can continue from the quadratic equation here, and we try to solve for it. Very obvious that this equation cannot be factorized, so I have to use a formula for quadratic. So to get the value for tangent x, what is the formula? Do you remember? It is actually negative b, so negative b. Okay, plus minus square root b square minus 4ac, so b square minus 4, then a, then c. Then divided by 2a, so divide by 2 and then 8. Okay, so from here, eventually, right, if you try to simplify the values here, the formula here, by right, you'll get two values. One value is 3 sec 3 plus square root 35 divided by 2. Another value for tangent x will be tangent x equals to 3 sec 3 minus square root 35 divided by 2. Alright, okay, then after that, of course, you need to continue to solve the equation here. So how to solve it? You have to solve it separately. So I solve the first equation first. So this first equation here, this one, we move forward, yeah, this one. Okay, so basically it's a positive value, right? Okay, it should be a positive value. So I try to get the basic angle for this value first. So basic angle should be 79.8. You get tangent inverse, then 3 sec 3 plus 35 square root divided by 2. Okay, so by right, when you press calculator, then you will get 79.8 here. Alright, yeah, but this is the basic angle. Okay, then if I want to see which quadrant I want to get the answer, right, this is basically how I refer. I'm having the quadrant graph, all sine, tangent, cos. And then I know that my basic angle is always in the first quadrant, so I label it as theta. To get the answer in the second quadrant is 180 minus theta. Third quadrant is 180 plus theta. Then the fourth quadrant is 360 minus theta. Okay, and after that, for this particular equation here, I'm having tangent positive. So for tangent positive, right, which quadrant will give you tangent positive? So the first quadrant will give you the tangent positive. That means I want to accept the answer from first quadrant, which is the basic angle itself, so 79.8. All right, then after that, in second quadrant, is it tangent positive? No, right? Then in the third quadrant, is it tangent positive? Yes. So I want to accept the answer for this quadrant. So you should take 180 plus basic angle. But if you have a look for the requirement in the question, they actually did mention that your x should be from 0 until 180. So that means you only want to consider your answer for x, which is in the first two quadrant only. So that means what? That means in the third quadrant, I no need to accept the answer because although the tangent is positive here, but because it is already out of range, so I'm not going to consider the answer from this part. So that means I will stop for this equation. So for this equation, I have one solution here. All right, then after that, I go for the second equation here. So for this second equation, I also want to get the basic angle, right? Okay, so what's the basic angle for this particular equation? All right, so before that, you have to check, yeah, what's the value for 3 sub 3 multiply with square root, oh sorry, 3 sub 3 minus square root 35. 3 sub 3 minus square root 35. Let me press the value out, divided by 2. So by right, you'll get the negative value. This is the negative value. Okay, so this value is negative. And then when you want to take the basic angle, right, you have to make sure that you change it become positive value first. All right, so don't make it become negative, you should change it become positive value. So when you're having tangent inverse positive, okay, so it should be square root 35 minus 3 sub 3 divided by 2. Okay, so the basic angle that you get should be 19.8. Alright, so please take note on this one. You have to make sure that to find the basic angle, you must have this value, which is a positive value, because our positive value are always in the first quadrant. So first quadrant, everything is positive. Understand what I say or not? Okay. Then after that, if I want to get the answer for the equation with tangent and negative, so which quadrant will give you tangent negative? So in the first quadrant, is it tangent negative? No, right? So I don't accept the answer from this part. I go to the second quadrant. In this quadrant, is it tangent negative? Yes, right? So I want to accept the answer from here. So how to get the answer for second quadrant? You take 180 minus the basic angle. So that means you take 180 minus 19.8 for this equation. So I'm having 160.2. Alright, so in short, for this question, right, I'm having two answers. One answer is in the first quadrant for first equation here. Another answer is x equals to 160.2 for second quadrant. I'm not going to continue with the third and fourth quadrant because in the question, they did mention that our answer is basically from quadrant number 1 and number 2 only. Alright, yeah, so this is how we solve question number 4. Alright, so now we are at question number 5. The square root of this complex number can be expressed in the Cartesian form of x plus yi, where x and y are real and exact. I think you need to highlight the keyword exact, yeah? By first forming the quadratic equation in x or y, find the square root of this complex number in exact Cartesian form. Alright, so you can see that when we take the square root of this complex number, our final answer is still a complex number. Alright, yeah, so to solve this question, what we can do is like we try to make it like this. So I take the square root of this complex number. The final answer is still equals to a complex number x plus yi. Alright, so to get the x plus yi, I have to continue to solve this equation. Okay, and then you have to remember that your value for x and y must be exact value, right? So let's start. I want to get rid of the square root outside here. I will take square both sides. So when I take square both sides, this is what I get. So I'm having x plus yi squared. Okay, then after that, I try to expand the complex number. So you're having x squared plus 2xyi, okay, then plus yi squared. So y squared means it will give you y squared I squared. And then you need to know that what's the value for I squared here. So I squared is basically equals to -1. So don't forget about that. All right, it is important details that you need to know. Right, then after that, when you're having I squared equals to -1, right? Okay, so it will become negative y squared. So I group all the real number together. I'm having x squared minus y squared plus 2xyi. Okay, so this is what I get now. And what should we do now? Next is we try to solve the equation. But how can we solve the equation? What we can do now here is we try to compare the real part with real part, imaginary with imaginary part. So what's the meaning of it? So you can see that this is my real number, right? In a complex number, this is a real part. I compare this real part with the real part on the right, which is x squared minus y squared. Alright, so from here I form the first equation where I have x squared minus y squared equals to 4. Equals to negative 4. So this is my first equation here. And after that, what is the imaginary part? So the imaginary part of the coefficient is 6 square root 5. So you compare it with x, y times 2. Okay, so 2xy equals to 6 square root 5. Okay, so this is my second equation here. So I'm having 2xy equals to 6 square root 5. And maybe I can put y equals to 6 square root 5 divided by 2x. So I'm doing it like this because I plan to substitute the y into the equation number 1 later to solve. Okay, so I have 3 sub 5 over x, and this will be my second equation. Alright, then after that, what can I do next is I try to solve the two equations here simultaneously. That means I substitute equation number 2 into equation number 1. Alright, so you can substitute inside now. Okay, so sub equation number 2 into equation number 1. So what do I have here? So x squared is x squared minus y squared. So the y now is 3 sub 5 over x. So 3 sub 5 over x squared. Okay, then equals to negative 4. Alright, then I multiply the square in. So I'm having 3 squared is a 9. So 9 square root 5 is a 5. Square root 5 squared is a 5. Divided by x squared equals to negative 4. So what can I do from here? I want to get rid of the x squared in the denominator. So I multiply every single term by x squared. So I'm having x power 4. Okay, then plus 4x squared. Then minus 9 times 5 is 45 equals to 0. Okay, so the negative 4 on the right originally I multiply with x squared and I move it to the left. So I'm having a positive x squared here. So if you have a look for this particular equation, basically it fulfills the hint in the question where they said by first forming a quadratic equation. So I'm having a quadratic equation here. But in general, right, this quadratic equation still belongs to a quadratic form equation where you can try to factorize them into x squared and x squared. Okay, so negative 45 means that you need to have 9 and also 5. Plus 4 means you have plus 9 minus 5. So that you can get a positive 4. Okay, so when you factorize it and you try to solve it, I'm having x squared equals to 5. And then x squared equals to negative 9. So for this part, we will try to ignore it and we don't solve the equation. Because in the question also, they did tell us that the x and y will be the real number. Real and exact. So this one, when you solve it, you can't get the real number, right? So you just ignore it from here. Okay, then for the x squared is a 5, so when you want to take the square root, you should consider the plus and minus sign, so plus and minus square root 5. Okay, then after you get the value here, of course you need to continue to figure out the value for the y. Okay, so when x is equals to positive 5, what happened to your y? Okay, so your y, you substitute into your equation, so you're having 3 sub 5 over sub 5, right? So you're having a 3. Then when x is equals to negative square root 5, then of course your y value will become 3 sub 5 divided by negative sub 5. So from that, you get a value of negative 3. Right, so when you solve under this part, then basically your answer is out already because you are having both the value for x and also the y. So what does it mean here? The conclusion for this question will be the square root of the complex number negative 6 plus 6 sub 5i. You'll get two answers here. The first one is sub 5 plus 3i. Another one is negative sub 5 minus 3i. Okay, so this is the answer. for the square root of this particular complex number. Okay? Alright, so some students, if they don't want to write out this one, some students, they might want to rephrase it, become plus and minus, cert 5 plus 3i also can. Basically, they are the same meaning. Alright, it is just see that whether you want to express it out one by one or you have to compile it in a set, in a pack like this. Okay? Yeah, so basically, this is how we solve the question number 5. This is how we actually find out the square root of a complex number. Okay, so question number 6. We are having the variable x and also the theta satisfy the differential equation like this. Okay, and they give us the initial boundary or the initial value, which is x equals to 5 and also theta equals to 0. They want us to solve the differential equation and obtain an expression x in terms of theta. Right, so basically, our main idea is to solve this differential equation. Alright, so in our syllabus, right, the differential equation are the separable variable equation. So what should we do is like, first step, you have to separate your variable. You have to group all your variable x at one side and also all your variable theta at another side. Okay, so first step, I want to try and move the 1 over 5x plus 1 to the left, so that I can group all the dx and also the variable with x on left hand side. Then the d theta here, I want to move it to the right so that I'm having sine square 2 theta and d theta on the right. But the problem now is this is not a fraction. So maybe before I try to move the variable, right? I try to adjust the fraction a little bit first. So x over 5 plus 1, if I try to make them into one fraction, it should become x plus 5 over 5. Then sine square 2 theta. Okay, so I have to make it become one fraction first so that I can try to move the x plus 5 to the other side, where it will become 1 over x plus 5. Okay, so how about the 5 here? For the 5 here, if you want to bring it over also can. You want to keep it on the right hand side also can, no problem at all. Alright, so for me, I bring it to the left hand side so that it become 5. So I prefer to have a 5 instead of a half, instead of 1 over 5 on the right. Okay, but it is not wrong that you keep your 1 over 5 on the right, no problem at all, yeah? Right. Then after that, you've moved this fraction already, then on the left hand or on the right hand side, you still have sine square 2 theta with you. And also I want to bring the d theta go up, become like this on the right hand side. Okay, so now you can see very clearly that we successfully separate the two different variables to two different sides. So if you want to solve this differential equation, you can start putting the integration sign. Okay, so now you need to investigate and see how can we actually try to integrate both sides here. Alright, so let's have a look for the left hand side here. What is the formula that's related to the integration here? Okay, so you need to think about how can we integrate 1 over ax plus b. So to integrate 1 over x plus b, basically you're having ln ax plus b, then divided by the differentiation of ax plus b. Then you're having the a here, then with a plus c. So this is basically the formula that we are using for the left-hand side. How about the right-hand side here? Okay, so for the right-hand side, when you're having anything with sine square, cos square, you can't integrate it directly like this. Alright, so you need to actually aware, okay? So what is the correct technique for you to integrate the sine square or cos square? So I did mention in my lecture before, where you're having sine square, cos square, sine power 4, cos power 4, all this even number, even power for sine and cos. You have to apply double angle formula. Okay, because the double angle formula can reduce the square here, become something without the square. Understand what I said or not? So it is a general idea. You must have this concept in your mind. All right. So when you're having sine square, cos square, then sine power 4, cos power 4. Basically, the idea is you are using double angle formula to reduce the power first, then only you start the integration. Okay. So what is the double angle formula that I can use with the sine square? So I want to use cos 2 theta equals to 1 minus 2 sine square theta. I'm choosing this formula is because of in my equation here I'm having the sine square. So I want to have a sine square here. But if you try to observe the angle, right, this angle here in the question is 2 theta. But in my original equation for double angle formula, it is a theta. What can I do is, you are actually allowed to modify the theta become 2 theta. Just now if I have theta, then my double angle formula is 2 theta. So now if I modify this angle as 2 theta, so what happened to this original angle here? You need to multiply with 2 and it will become cos 4 theta. Okay, then after I move it in this way, then you can see that I can rephrase my equation. Sine square 2 theta will be equals to 1 minus cos 4 theta divided by 2. And now I want to substitute the sine square 2 theta by using this equation, and you can see that, oh, it become no more square, right? When you have no more square, no square in the trigo, then you can integrate it directly. So this is one of the expression that you can integrate directly without the square. Okay, all right. Then now let us continue. Okay, so for the left hand side, right, 5 on top is a constant, so I don't bother it, I just copy it. And then when I'm having ln x plus 5, so I bring in, 1 over x plus 5, if I want to apply the integration, I will have ln ax plus b, so I will have ln x plus 5. Divided by the differentiation of the x plus 5. Differentiate x, you get a 1. Differentiate 5, you get a 0, so it is divided by 1. Okay, I didn't put a plus c here for differential equation because I want to group all my constant term on one side only. So later I'll put it on the right. So I don't write out any constant term on the left, right? Okay, then for this one, let us continue. We will need to replace it by using this double angle formula. So I'm having 1 minus cos 4 theta divided by 2. Okay, so this one I haven't integrated yet, so I have to continue to integrate it. Okay, you're having the half, right? I take it out as a constant term. When I take out the half, first term here is a 1. Integrate 1, I will get the theta. How to integrate cos 4 theta? So again, you have to recall back what is the related formula. Integrate cos m theta. What do I get? Yeah. Okay, so you should know that if I integrate cos, I'll get a positive sign. M theta. Then you differentiate the m theta, you get the m, right? So I have to divide it by the m. Okay, so this is a general formula when you want to integrate anything with cos m theta. So same thing happened here. I factorized out the half just now. For the cos 4 theta, right, I want to integrate it. So when I integrate, I will have sine 4 theta divided by differentiation of 4 theta, you get a 4. Okay, then I have completed the integration, so I put a plus c on the right hand side. So this plus c actually include the constant on the left hand side just now. All right. So you can see that I just put everything, every constant in one letter only, which is a plus c. Okay, then let's continue further. How can we get the value of the c here? You have to use the initial value given in the question. So they said when x equals to 5 and theta equals to 0. So you can write it here lah. So given that the x is equals to 5 and also theta equals to 0, so what do I get if I substitute it into the equation just now? So I'm having 5 ln 5 plus 5 is a 10, right? That equals to half. Substitute the theta inside, you will have 0 minus 0. Okay, then plus c. So from here, you can also see that your value of c should be equals to 5 ln 10. Okay, so 5 ln 10. Okay, then this is not my final answer yet, because if you try to read the question again, they ask you to solve the equation. At the same time also, they want you to obtain an expression x in terms of theta. So x in terms of theta means what? Means that you have to rewrite your equation again. Okay, so let's start, yeah. So to rewrite the equation, I substitute the c into my solution first, the particular, to make it become particular solution. Okay, I'm having 5 ln x plus 5 equals to half theta minus 1 over 8 sine 4 theta then plus C. C is 5 ln 10. Okay, so now you have to remember that for what I want to do now is I want to have the equation x in terms of theta. So that means I want to group everything, okay, all the things here that is x on the left, then all the theta on the right. There are many ways for us to do that, all right? So for me, the first step I want to do is like I want to get rid of the 5 here, the 5 in front. So I divide every single term by the 5. So you're having 10, 1 over 10, then 1 over 40. I think I made a careless mistake here, right? This one should be 4 theta, right? Okay, so I'm having sine 4 theta here. Divided by 5, you're having ln 10. And then when I want to group all the equation, right? It will be easier if I group all the same pattern together. So I'm having ln x plus 5 and also ln 10. So what I do here is I bring it over, become ln x plus 5 minus ln 10. Okay, so next, how can I group these two ln together become single ln? Okay, so from here to here, I just want you to recall back, yeah? Do you still remember that you are having ln A minus ln B can be written as ln A over B? Okay, so same thing happened here. I'm having ln A, which is x plus 5, okay, minus ln B. The B is a 10, so you have A divided by B, which is a 10. Okay, then equals to 1 over 10 theta minus 1 over 40 sine 4 theta. Okay, then next step. So what should I do for next step? Now, I want to bring the ln over. Okay, so this ln is very troublesome. I want to bring it over. So you need to know that when you want to bring the ln over, right, it will become the base E. Then all the number on the right will become the power. And you will see this one. So I'm having 1 over 10 and then x plus 5. When I bring the ln over, it will become E with the power theta over 10 minus sine 4 theta over 40. Okay, then next step, bring the 10 over first. It will become 10 e power theta over 10 minus sine 4 theta over 40. Okay, so one last step, you bring the 5 over, become negative. So minus 5. Okay, so this is how we get the differential equation, our particular solution, x in terms of theta. All right. Yeah, so some students will say that, oh, can I make the power here become the decimal number? As an example, like I'm having 10, then E, 1 over 10. Theta over 10 means 1 over 10, right? So you're having 0.1 theta. So they write as 0.1 theta, then minus 1 divided by 40. So you get a long decimal number, 0.025. So 0.025 sine 4 theta, then minus 5. Now, if you want to put it like this, also can one, no problem at all. All right, but you have to make sure that you know, yeah, the negative 5 belongs to the same level as the base number. Okay, the negative 5 is not belongs to the part of the power of the E. So you have to take note on this. Okay, all right, yeah. So basically, this is how we solve question number 6. Okay, so question number 7, we are given a diagram, and then this is the curve for the diagram. Okay, y equals to x power 3, then cos 2x for this range, for this domain. The curve has a maximum point at M. This is the maximum point where x equals to p. The x coordinate and the maximum point is a p, right? So show that p satisfies the equation of this one. All right, so before we can show it, right, we need to know where to start with. So the p basically is the x coordinate of the maximum point, right? So highlight the keyword maximum point. Every time when you want to find the maximum point, what we need to do is like we need to apply differentiation. You need to find the dy dx first. After you find the dy dx, you have to let it become 0. Then only you can get the x coordinate for the maximum point. So this is what we are going to do. Alright, so let's have a look for y equals to x power 3, then cos 2x. Okay, so you can treat the x power 3 as the first bracket, cos 2x is the second bracket. So you're having two brackets here, and you multiply them, right? Therefore, when you want to apply differentiation, you have to apply the product rule because it is the product of two different brackets. Okay, so for me, usually what I do is I remember the process. Of course, you can refer to the formula booklet for the product rule. Yeah, so I'm applying product rule here. So what I do here is I copy the first bracket first, differentiate the second. So differentiate cos 2x. What do you get when you want to differentiate cos 2x? So differentiate cos, you should have negative sign. So you're having negative sign, copy back the angle. Then after that, you have to differentiate the thing inside the cos. So you need to differentiate 2x now. Differentiate 2x, you get a 2. So I have to multiply with the 2. So you differentiate cos 2x, this is what you should get. Then plus, just now you copy the first, differentiate the second bracket now. Right, so now you have to copy the second bracket, differentiate the first. So differentiate x power 3, what do you get? You have 3x squared. Alright, then after that, I try to simplify my equation here. I will have the front part here, I'm having negative, so I move it to the back. So this one is a positive, I bring it in front. So I'm having 3x squared cos 2x, then minus 2x cubed sine 2x. Okay, so I try to simplify and rearrange my dy dx. Then I have to let the dy dx equals to 0 if I want to find the x coordinate of the maximum or minimum point. So I let it equals to 0. I try to solve this equation. And how can we solve the equation here? Basically, what I can do is that I can factorize out the x squared. Then I'm having 3 cos 2x minus 2x cubed, then sine 2x. Okay, then after that, x squared equals to 0, and also this equation equals to 0, right? So I continue to solve this. So 3 cos 2x minus 2x cubed sine 2x equals to 0. Okay, then now, because I already know that the x coordinate for the maximum point is the p, right? So that means if you want to substitute all the x by using p at this stage also can. Alright, so up to you. So maybe for me, I'm changing it. So I'm having cos 2p minus 2p cubed sine 2p equals to 0. Then how can I get this particular equation here? So you have to rearrange your solution so that eventually you get this equation. Okay, so how can I continue from here? Maybe you have to observe a little bit. Yeah, what do you have in the equation here? You're having the tangent inverse. But for me, I don't have any tangent inverse in this case. Right? Yeah, so first step, maybe I need to continue to make sure that I got the tangent inverse. Alright, so I try to put it in this way first. Okay, so from here, I know that if I want to get the tangent, I should bring and group my sine and cos to one side. Okay, then what else do I have? Let me think about it. I think I did the careless mistake earlier. When I factorize out the x squared, there's no more x cubed here. This one should be the x. So sorry for that. Yeah, then the next step also, this one, I will be having 2x only. Okay, then the next part, I'm having 2p only. This is also 2p only. Yeah, I think this is the correct one. I accidentally forget to factorize out the x squared from the top. Okay, so I'm having sine 2p divided by cos 2p, then I have 3 divided by 2p, right? Okay, so from here, you successfully see that I successfully get the tangent 2p equals to 3 over 2p. Then I try to compare my answer with what they request on top. So you see, this is what they want. Okay, so I want to have tangent inverse 3 over 2p. I already got 3 over 2p here. So to get a tangent, I just bring the tangent over, become tangent inverse. So 2p is equals to tangent inverse 3 over 2p. And then finally, you just bring the 2 over and you successfully get the equation that they want you to show. Right, so this is how we get the equation here for the part A. Okay, so to start, basically you still need to refer what is the useful information given in the question. Then you start from that and you slowly rephrase it. Okay. All right, so this is what you have for part A. Yeah. Then let's continue to part B. What they want us to do in part number B. Okay, so let's have a look. For part B, they want to show by calculation the P is from is from 0.5 to 0.7. Okay, so for this question, right, there are more than one way for you to do it. For me, I'm using the sign change method. Okay, I'm using the sign change method where I try to figure out, substitute the value for 0.5 and 0.7, right? What is the sign? Is it a positive sign or negative sign that I get? So this is what I call a sign change method, right? Okay, so before we start, just let's have a look for the equation that we have just now first. Okay, so from first part, this is the equation that we get, yeah? P equals to half tangent inverse 3 over 2p. This is what we get from first part. Okay, so now to find out the sign change, I need to make this equation become a function in terms of p. So how to make it become the function? You have to bring every term to group them at one side only. So I'll be having half, then tangent inverse 3 over 2p minus the p. Okay, then next one, I have to substitute it into my equation. So they said the p lies between these two values, right? So the sign change should happen between these two values. So I substitute as f 0.5, I substitute 0.7 into function f also. Then you press calculator to help you. So when you press the calculator, by right, this is the answer that you should get. Actually, this value itself is not important, but we actually want the sign only. Is it a positive value or negative value only? Okay. Alright, so when I substitute 0.5 and 0.7 into the function, I realize that, oh, okay, one value that I got is a positive value, another value that I get is the negative value. So this is what I meant, it is meant by sign change. Alright, so once you see this one, you got see the sign change here, then you can write a conclusion related to this one, where sign change can be seen. Okay, so hence the P actually lies between 0.5 until 0.7. Okay. Oh yeah, then one more reminder to to remind you, when you want to find out the sign change, right, you substitute the value 0.5 and 0.7 into your function, correct or not? So a small reminder, yeah, when your function involve anything with trigo inverse or trigo, okay, don't forget to change your calculator into the radian mode, because all the value that we substitute into a trigo or trigo inverse basically is all radian, not degree. Alright, so your calculator also have to make it become radian. If not, then you might not get the sign change seen here. Okay? Alright, so this is what you have for part B. So let's continue to part number C. Okay, for part C, they want you to use an iterative formula based on the equation in part A to calculate P correct to 3 decimal places, and then each iteration to 5 decimal places. Okay, so let's have a look for the equation first, yeah? So I'm having P equals to 1 over 2 tangent inverse 3 over 2p here. Okay, so this formula is the iterative formula. They want us to use this formula, then calculate the p correct to 3 decimal places, right? So you have to use calculator to help us get the value of p one by one until we get a repeated value. Alright, so let us decide what is the first value of the p first. P1. Okay, so for this question, they didn't mention any initial value for the p to start with. then basically you can start with any number that you like, but the suggestion is try to use the value that's close or that it is related to 0.5 or between 0.5 to 0.7. Okay, so some students say, oh, I want to use 0.5, can or not? Can, no problem. Some students say, can I use 0.7? Okay, also can. Some say, can I use the midpoint, which is 0.6? Also can, as long as your value is not too far away from what they suggest here. Okay, so for my example here, I'm using 0.5. So that means what? That means I have to substitute the 0.5 into my iterative formula. So 3 over 2 multiply with not 0.5, it's 0.65 to get the value. Because I will need to repeat the process maybe more than a few times, quite a few times. So I can use the calculator to help me. So when I want to use the calculator to help me, right, the very first step is try to key in the iterative formula. The iterative formula is this one. So first of all, I want to make sure that my angle is with radian. So maybe I have to change the radian first. So shift radian. So I want to put it as 4. This is a radian. Okay, I don't know whether you can see it or not. So I have to make sure that it's in radian mode. After that, I key in the right hand side of the equation. So the right hand side of equation basically is tangent inverse. So I want to have tangent inverse. Okay, then 3 over 2. So 3 over 2p. So the 2p here I put it as 2x. Okay, then after that it is divided by 2, right? So divided by 2. Okay, so I successfully pressed in the calculator already. Then now I want to find all the iteration here. The first initial value that I use for this case is 0.65. But of course, you can use any value that you like, as long as not too far away from 0.5 and 0.7. Okay. Alright, so first step, you try to press calculate in your calculator. They will ask you what is the formula or what is the value that you want to key in. So the formula that you want to key in, the value of x that you want to key in is 0.65, right? So you just press 0.65, then you press the equal sign. So you get 0.5809 blah 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 blah. To write out your answer, right? This is all your iteration. So they say iteration correct to 5 decimal places. So let's have a look for this one. 5 decimal places means 58094. Agree? So you'll be having your P2 as 0.58094. Then how about for the next value, P3? So same thing happened here for P3, you have to substitute 0.58094 into your iterative formula. So you need to rewrite your equation one more time. You can directly press calculator. So you go back to your calculator, you press calculate again, then you key in the value 0.58094. 094. Okay, then you press equal sign. Then the next value that you get is 0.60065. Okay, so you rewrite your answer 0.60065. Okay, then continue for next one. Repeat the same process, press the calculate, key in the value 0.60065. Press the equal sign. Then you're having 59496. So 0.59496. Okay, so maybe some students will ask, hey, when do I stop? When do I need to stop if I want to repeat this process? Alright, so to stop, you need to check your answer for 3 decimal places. Okay, so as an example, for P2, right, the second iterative, the 3 decimal places answer is 0.581. For the next one, the 3 decimal places answer is 0.601. You can see that these two values are not repeated yet, right? So you cannot stop. You have to continue for the 3 decimal places answer. Then what is the next one here? You will get 0.595. So all the 3 values here are different. So you cannot stop yet. So you have to continue the process, the iterative process, until the 3 decimal places answer repeated. Okay, so I continue for P5. I will substitute in 59496. Okay, so same thing happened. Calculate 0.59496, then equal sign. So you see 59659. Okay, 0.59659, right? Then Maybe you double check again. What is the 3 decimal places answer for this? You have 0.597. Still not repeated yet, so please continue further. Calculate 0.59659 equal sign 59613. So 59613. So 3 decimal places answer is 0.596. Not repeated yet, okay? Please continue some more. 59613. Calculate 0.59613 equal sign 59626. So 0.59626. This one, 3 decimal places answer is 0.596. Oh, so you can see that the 3 decimal places answer has been repeated here. Okay, for me personally, I usually want to make sure that it is safe. I will still continue with one more extra one. All right, so press calculate, then 0.59626 equal sign. Then you have 59622. So 0.59622. So when you look at this one, right, the 3 decimal places answer is still 0.596. So for me personally, I will prefer to look for the answer repeated 3 times. Some students, they will stop at 2 times. For me, I want it to be safe, right? So I always keep it as 3 times. So you can see the 3 repeated answer for 0.596 already. Then you can stop the iteration and you can just straight away tell them that the root is basically 0.596. Okay, alright, so basically this is how we get the answer for the iterative equation. So make sure that you know the process well. So again, a very small detail is you have to always remember every time when you have any value substitute into the trigo or trigo inverse, right? Especially that involve all the differentiation or integration one, then please make sure that you keep your calculator in a radian mode. Okay, if you put it in degree mode, you won't be able to get the answer, right? Okay, so this is how we solve question number 8. Oh, sorry, number 6. Okay, so we are now at question number 8. So there are 2 lines where the vector equations are shown here. All right, so they want us to show that the lines are skewed. Okay, so what is the process that we need to go through? So basically, first of all, before we can show that they are skewed, we need to show that the lines are not parallel. Okay, so what should we do is like we try to figure out the direction of the line first. So maybe for this one, I will call it as direction of the first line. I label it as P. Then this one is the direction of the line for second line. So this is a Q. Okay, so first of all, you can see that are they a multiple of each other or not when we are looking at the direction of the line. It is like a gradient. Okay, so you try to compare and see are they a multiple of each other or not. If let's say not, then that means they are not parallel to each other. So just like when we are talking about gradient, right? If let's say the gradient are equal, then basically the line are parallel. If the gradient are not equal, the line are not parallel. So we have to prove that they are not parallel first, but we are looking at the direction of the line. Okay, so from here, the very first thing that we need to mention is 2, 3, and 1 negative is not a multiple. It's not a multiple, sorry, it's not a multiple of the direction of the second line, which is -1, -2, and also a 1. Or the other way around also can. All right, so this one actually tells us that the lines are not parallel. Lines are not parallel. Okay, so when the lines are not parallel, there are 2 possible cases here. When the lines are not parallel, it is possible that the line intersect with each other, or the lines might be skewed. Okay, so to check and see whether are they intersect or are they skewed, we have to let R1 equals to R2. So this is the second thing that we need to find out. Yeah, so let R1 equals to R2, and we combine the vector together for the vector equation. So I'm having negative 1 plus 2 lambda for the x, then 3 plus 3 lambda for the y, and negative 1, negative 4 minus lambda for the z equals to R2. So for R2 is 2 minus mu, then negative 3 minus 2 mu, and also negative 1 plus mu. Okay, so from here, when I let R1 equals to R2, right, I try to solve for the value of lambda and also the value of the mu. If the lambda and mu, the value that you find out just now, right, is consistent, or maybe is correct for the third equation that you haven't used, then basically they are intersect. If let's say the equation is not fulfilled, then it should be skewed case. Alright, so I don't know whether you understand what I say or not, but we try out here. Okay, so I want you to have a look for the first equation here. I will treat this blue color one as a first equation. Okay, then maybe the other color. What color do I have? Purple color, this one is the second equation. And after that, the yellow color will be the third equation. So basically you're having three equations here, but you have two unknown only, right? So one is lambda, another one is mu. So you try to use any two of the equation and solve for the value of mu and lambda. So let us solve. Okay, so for me, I'm using equation number 1, then I add it together with equation number 3. Okay, so negative 1 plus negative 4, you get negative 5. 2 lambda plus negative lambda, you have a lambda. 2 plus negative 1, you get 1. Negative mu plus mu, you get 0. So from here, you can see that the lambda is basically equals to 6. So when the lambda is equals to 6, what happened to your mu? So again, you can substitute the lambda as into either the equation number 1 or the 3 that you used just now to get the mu. So I substitute into the 3. Okay, so from 3. Okay, so what do I have here is negative 4 minus lambda, which is a 6, equals to negative 1 plus mu. Therefore, you get your value of mu here, right? So the value of mu will be equals to negative 9. Alright, and now after I get the value for lambda and also the mu, now I want to check whether the case here, the line here belongs to intersection case or are they belongs to the skewed case. So to check, what you need to do is like you have to substitute your value of lambda and also the mu into the equation that you didn't use just now. So as an example, I'm using 1 and 3 to solve for the value of lambda and mu, right? Therefore, when I want to check whether the equation is true or not, I have to use the second equation that I haven't used just now. Understand what I said or not? So if let's say just now you are trying to use the first and second equation to solve for the lambda and also the mu, then now for the checking part, you have to use the third equation. So you are trying to check by using the equation that you didn't use to solve the lambda and mu just now. Okay, so I'm solving using 1 and 3 just now, right? So now I have to check from 2. Okay, so what is the equation on the left hand side for equation number 2? So you're having 3 plus 3 lambda. So 3 plus 3 lambda means that you're having 3 plus 3 times of 6. So you're having 21. And right hand side, okay, so you're having negative 3 minus 2 mu. Your mu is negative 9. And you're having 15. Then you realize that the value of left hand side is not equals to the right hand side, right? Okay, so that means this also tells you that the conclusion is the lines are skewed. Okay, so some students will ask now, what about if let's say the left hand side value is equals to the right hand side value? So if let's say the left hand side value equals to right hand side value, that means on these two lines are actually intersect with each other. That means they touch each other. Okay, so that's the conclusion. So if let's say left hand side not equals to right hand side, then basically the lines are skewed. Alright, so one more extra information for you to know about this part is, like what I did just now, right? I'm using the first equation and third equation to solve. And then I check it by using the second equation. So in the skewed case, right, if let's say you are using the different equation to solve, like maybe you didn't use 1 and 3, you use 1 and 2 to solve, right, the value of lambda and mu that you get will not be the same as what I get here. But if it is the intersection case, then no matter which two equation are you using, the lambda and mu are always same. The answer for lambda and also the mu will be the same, no matter what equation are you using. Okay, so because this is a skewed case, therefore I use 1 and 3, I get mu is 6. Lambda is 6, mu is -9. If you are using 1 and 2 to solve, then you might have other value for lambda equals to something else, then mu equals to something else. In this case, basically, it means that the lines are skewed also. Alright, but of course, when you want to check, the best way to check is use the equation that you haven't used before to solve, and then you check the value of left-hand side and also the right-hand side. Right? Yeah, so this is what we have for part A. This is how we solve, how we prove the lines are skewed. I want to emphasize here, before you prove that the lines are skewed, you have to tell them that you have to figure out that the lines are not parallel at first. Because only when the lines are not parallel, then only you have the possible case, which is the intersection case or the skewed case. Alright, so you have to show these two main points here. Right, okay, so let's continue to part B. Okay, so for part B, they want you to find the obtuse angle between the direction of the two lines. So highlight the keyword obtuse angle. Right, so to find the obtuse angle, we have to use the formula for the dot product where P dot Q equals to modulus P, modulus Q, and then cos theta. And please note that the modulus P and modulus Q here, right, basically it should be the direction of the line. So I think in the previous part, I did show you, right, I did tell you that what's the direction of the first line. So the direction of the first line basically is 2, 3, and -1. And how about the direction of the second line? It is equals to Q, right, which is -1, -2, and also the 1. So you have to pick out the direction of the line first before you can find the angle between the line. Okay, so to find the angle between the line, we are using the dot product and the cosine rule to solve it. Okay, so since I already know the direction of the line, right, so I just apply it in our formula. So P dot Q, okay, then equals to modulus P. So what's the modulus P that you get? How to find the magnitude for P? It is 2 square plus 3 square plus -1 square, right? Then how about the Q? Modulus of Q will be -1 square plus -2 square plus 1 square. Then you are having cos theta. Okay, then after that, how can we apply the dot product here? So you are taking x multiplied with the x component, so you are having -2. Then plus y multiplied with the y component, so you're having -6. And lastly, you're having z multiplied with the z component, you're having plus -1. Then on the right hand side, when you try to add on the terms in the square root, so you'll be having square root 14 multiply with square root 6 and then cos theta. Simplify the numbers on the left, you'll get -9. Okay, then if I want to continue and find the cos theta, I'll be having -9 divided by square root 14 and also square root 6. Okay, then now you can see that on my right hand side here, the value is actually a negative value. So negative value actually tells you that if you take cos inverse later, by right you will get the obtuse angle. If let's say the question is asking for acute angle, then don't forget to change this value become positive because acute angle means in the first quadrant. So the value should be positive. Okay, and now since you already can see very clearly that the value here is the negative value, right? So by right, it is true that you should get the obtuse angle here. Okay, all right. So now to get the theta, you have to take cos inverse. Then press the calculator to help you a little bit on this. Okay, so if you didn't do any careless mistake, by right you should get a long value. Then I will cut it short to 1 decimal place for the answer in the angle, so which is 169.1. So for this question, since they didn't tell you anything about the details of the angle, right? So if you want to keep your answer in how to say in the radian form also can. So for degree, it should be 169.1. Then let me check what is the value for radian. Okay, so multiply with pi divided by 180. So by right, I'll get 2 point. If I didn't do careless mistake, yeah. So the answer for radian should be 2.95 radian. Okay, yeah. So this is how we solve question number 8. All right, so question number 9. Okay, we are given a polynomial, and then we are having a and b are constants. So it is given that x minus 3 is a factor of px. So the word factor is a keyword, tells you that there's no remainder when you divide the polynomial by using x minus 3. And after that, the first derivative p prime x is divided by x minus 3. The remainder is 72. So the keyword here is the remainder. All right, so when you see this kind of question, basically you have to use the factor theorem or remainder theorem to solve the question. All right, so first of all, we are having px equals to 6x power 3 plus ax squared plus bx plus 9. Okay, so the first sentence given here is when the polynomial is divided by x minus 3, which is a linear factor, okay, a linear divisor, it is a factor of px. So the word factor tells you that there's no remainder when the polynomial is divided by x minus 3. It also means that if I want to apply the factor theorem, when I substitute, okay, so you try to assume that x minus 3 equals to 0. It is a factor, so your x is equals to 3. That means if you substitute 3 inside your polynomial, you should get no remainder. So no remainder means that it is equals to 0. Okay, so P3 equals to 0. This is what we call as a factor theorem because it gives us the detail where x minus 3 is a factor. So substitute 3, you'll get the remainder 0. Alright, so substitute 3 into the polynomial, you're having 6, and then all the x, replace it by using the 3. Sorry, it is a 3, right? And it is equals to 0. Okay, try to simplify the equation here. By right, you'll be having 162, then plus 9a plus 3b plus 9 equals to 0. Alright, so from here, I try to rephrase everything slowly, and I want to get the equation. A in terms of b, or maybe b in terms of a also can. So I will have this, b equals to negative 57, then minus 3a. And I assume that this is the first equation I get, because to get the value for b and a, I need two different equations to solve simultaneously, right? Okay, so I'm done with the first part of the question here. Then let's have a look for the second part of the sentence of the question given. They said the first derivative p prime x is divided by x minus 3, then the remainder is 72. So let's try to find the p prime x first. P prime x means that you differentiate the polynomial here. Okay, so what do I get if I differentiate p prime x? Let's have a look. So 6x power 3, differentiate it, you have 18. The power 3, you put it in front, right? So 6 times 3, you get 18. X squared, copy the x, power minus 1 become a 2, right? 3 minus 2 become a 1. Then the ax squared, you also bring the power in front. Ax squared, you bring the power in front, you'll be having 2a. Then copy the x, power minus 1 become a 1. Differentiate the bx, you'll get a b. Alright, so this is the first derivative of the polynomial, which is p prime x. Right, then after that, they said if it is divided by x minus 3, then the remainder is 72. So from the remainder theorem, it tells us that if you substitute 3 inside your p prime x, you'll get the remainder equals to 72. So it is equals to 72. So just now the keyword is factor, so no remainder. No remainder means that the remainder equals to 0. So for this part, okay, now they say the remainder is 72. Therefore, you can see that when you are writing it in, you'll be having the remainder equals to 72. Then the same thing happened here. You substitute the 3 inside your p prime x. So 18, 3 squared plus 2a, 3 plus b. Then we do the same thing where we try to rephrase B in terms of A or A in terms of B lah. So by right, if you didn't do any careless mistake, this is what you should get. Okay, I think I get this. B equals to negative 9t minus 6a. And this is the second equation. Okay, I think here is quite obvious. To get the value for B and A, you need to solve the two equations here simultaneously. I let 1 equals to 2. And this gives me negative 57 minus 3a is equals to negative 90 minus 6a. Try to simplify the equation here. Alright, then I will get the a equals to negative 11. At the same time also, substitute the a, go back to the equation 1 or 2, up to you. And you will get negative 24. This is how we actually get the a and b, by using the factor theorem and also the remainder theorem. Right, so let's continue to part B. For part B, they said when A and B have these values found in part A, factorize Px completely. Highlight the keyword factorize. Okay, so the word factorize tells us that it is related to factor, right? So I need to write out my polynomial first. So my polynomial is 6x power 3. The A is negative 11, right? Okay. Then B, what is the B here? The B is negative 24. Then plus 9. When they are talking about factorize, that means I need a factor to help me to factorize the polynomial completely. According to part A, I know that my factor is x minus 3 for the polynomial, right? So what I'm doing now is I try to apply long division so that I can further simplify the polynomial. Okay, I'll factorize the polynomial. I need to divide it by x minus 3 because x minus 3 is a factor for this polynomial. Alright, so you are trying to think about this. So something multiply with the x. You're referring it to the first term here only, right? So you try to put in the value. So think about something. Something multiply with x to get 6x power 3. So the something here should be 6x squared. And you're having 6x power 3. 6x squared also have to multiply with the negative 3. So you're having negative 18x squared. Alright, then you take the top term minus the bottom one. 6x power 3 minus 6x power 3, you get a 0. Negative 11x squared minus negative 18x squared, you'll be having 7x squared. Then pull down the other term, minus 24. Okay, then next one. Let's have a look for the next division here. So thinking about the x and also the 7x squared. Something multiply with x to get the 7x squared. So as the something here, the something here should be 7x. Multiply with x, you'll have 7x squared. Then same thing happens, 7x have to multiply with the 3, then you have negative 21, right? Negative 21x. Alright, then continue further. Okay. Also minus 7x squared minus 7x squared, you get a 0. Negative 24x minus negative 21, you're having negative 3x. Then plus 9. Then the last term, try to think about the negative 3x and also the x. A moment, yeah. Okay. Something multiply with the x to get negative 3x. What is the something? It should be negative 3. Negative 3 multiply with x, you have negative 3x. Then negative 3 also have to multiply with negative 3, you're having a positive 9. So when you want minus a term, basically you'll get no remainder. It is equals to 0. Okay. Alright, so for your information, we are having all the term here. This one is the divisor. The term on top, the expression on top is a quotient. Then the answer, the question here is the polynomial, right? And according to our knowledge, yeah, so we should know that the polynomial basically equals to divisor multiply with quotient plus remainder. This is what you should know about it. So this is how we form the polynomial by using the divisor, quotient, and also the remainder. Then we just try to rewrite our polynomial here again using the divisor, quotient, and remainder, right? Okay, so how can I rewrite from this part? Okay, my polynomial is equals to divisor, which is x minus 3. Quotient, what is the quotient? So the quotient is this one, 6x squared plus 7x minus 3. Okay, then plus remainder. So plus rx, right, the remainder, but you can see that there's no remainder here. At the bottom, there's no remainder. Therefore, the remainder should be plus 0. Then we have a look for the quadratic expression here. Double check and see whether is it able to further factorize or not, because they want us to factorize it completely. Okay, so we double check, and I think you should realize that it can be factorized, become 3x and 2x with a 3 and a 1 here. Then I should be having plus, right? So plus 9 minus 2, which is a 7. Okay, then you can see that now my polynomial is in 3 simplest bracket, and it cannot be further simplified or factorized anymore. So this is actually the answer for part B, where we factorize the polynomial completely. Okay, then let's continue to part C. For part C, they want us to solve inequality px is smaller than 0. And there's a purpose why in this question for part B, they ask us to factorize it completely, because you can directly use the result here and substitute in the part number 3. I'm having x minus 3, 3x minus 1, 2x plus 3. Okay, so I'm having x minus 3, then 3x minus 1, and also 2x plus 3. And I want to see what is the range of the value of x so that the whole polynomial is a negative polynomial or negative value or smaller than 0. For me, there are many ways that you can solve it. Then for me, basically, I'm using number line. From this bracket, x minus 3 equals to 0, I get x equals to 3. Okay, then for this one, I get the critical value 1 over 3. And then for this particular bracket, I have the critical value negative 3 over 2. Then after having these 3 values of x, what am I usually do is I will draw the number line. I'm having 3 value here. The smallest value is negative 3 over 2 according to the critical value that I get. Then I'm having 1 over 3. I'm having a 3. Okay, then for at the point 3, I'm referring to the bracket of x minus 3. So how can I get the bracket x minus 3 a positive bracket? So it must be going to the right hand side of the 3. When I substitute any value greater than 3, this particular bracket is a positive bracket. Right. Then let's have a look for the second bracket here, 3x minus 1. Looking at the critical value 1 over 3, I have to draw my arrow going to the right hand side, which means that if I substitute any value that's greater than 1 over 3 into this particular bracket, this bracket is a positive bracket. Simply happen for the last bracket here, taking negative 3 over 2 as a critical value, I need to draw the arrow to the right hand side. Okay, because it means that when I substitute any value greater than negative 3 over 2, this particular bracket is a positive bracket. And now you will see that all the line here, all the area with the line here means positive, because I want to make the bracket as a positive bracket, right? And if I multiply all the sign here together, positive, 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 then overall you're having positive. This bottom positive here is the sign for the px, the polynomial. Bracket number 1 multiply with bracket number 1 multiply with bracket number 2 multiply with bracket number 3. All are positive. Therefore, the polynomial is a positive part for this part. And then for the center part here, positive, positive, and negative. So positive multiply with positive is positive, right? Multiply with negative, you'll get overall negative. So in polynomial, the polynomial will getting a negative sign in this part of the value of x. Then the third one here, you'll be having positive. Then this one got 2 area without the line. So positive, negative, negative. Multiply these 3 signs together, you're getting positive for the polynomial. Then we're having negative, negative, and negative. Overall, your polynomial is also negative. So this is what you call as number line. Some students might want to use the table of sign also, can, up to you. Right. So for px smaller than 0, smaller than 0, this particular part here means a negative, right? So I'm looking for which part that give me polynomial, which is a negative part. So you can see that this is the part, yeah, this one, and also this part. So when do I have polynomial that is negative? So according to the number line that I draw here, you can see very clearly, when x is smaller than negative 3 over 2, then this polynomial will be negative. And also, when the x is between 1 over 3 until 3, this polynomial will be a negative polynomial. So by right, this is the answer that we should have. Okay, all right, so for this kind of question, right, they didn't fix any specific method for us to solve. You can use number line like what I show you here. You can use the table of sign, or you can even use try and error method to try to figure it out. Right, but basically the number line and also the table of sign is having the same concept. Just that for table of sign, you check the cell, the sign cell by cell. Then for me, I'm trying to draw using the line. Then I'm having the part with the line is positive. The part without the line is negative. Then we figure out which part of the polynomial is negative or positive. Right? Yeah, so this is how we solve the question number 9. Question number 10. I'm having the rational function like this, and they want us to express fx in partial fraction. Alright, so first of all, let's check whether is the rational function a proper rational function or proper fraction, or is it an improper fraction. So that's the first thing that we need to double check. Let's have a look for the highest power on top, which is the numerator. It is having a power 2, which is degree number 2. Degree 2 lah, alright. When you multiply the both x together under the denominator, x multiplied with x squared, you're having x power 3. Therefore, the degree at the bottom is the degree equals to 3. When the degree on top is less than the degree at the bottom, basically it belongs to the proper fraction. So when you're having a proper fraction, you can directly separate it into the partial fraction. Okay? If you're having improper fraction, then you need to go through the long division. Right? So I hope that you remember the cases here. Right? So that's the first thing that we need to check. After we know that it is a proper fraction, then we can separate it according to the denominator that we have. So for the denominator here, if you have a look, you are having 1 plus x and also 4 plus x squared. Alright, so let's have a look for the power of the x here. In the first bracket, it is the power 1. Outside the bracket, also power 1. So it is a linear factor. Then for the second bracket here at the denominator, you can see that the power for x is x squared. And then outside the bracket is also power 1. So this is actually the quadratic factor. Okay. Therefore, when I want to separate the partial fraction, right, I will be having a over 1 plus x, then plus, this one is 4 plus x squared. Because the 4 plus x squared, the degree is a 2 at the denominator. Therefore, the numerator should be 1 degree lower, which is bx, then plus c. Alright, so this is the very first step that you need to write out and show in your solution. How are you going to split it into the partial fractions? Then now our target is to find out the value for a, b, and c. To get the value for a, b, and c, I need to get rid of all the denominator first. So to get rid of all the denominator, you multiply the whole equation by using 1 plus x and also 4 plus x squared. Multiply the whole equation, yeah, with this one, the denominator, right? So if you multiply this whole thing on the left hand side, then your denominator disappear. You're having negative 7x squared plus 2x minus 6 equals to, multiply this whole thing on the first term here, you'll be having a 1 plus x and 1 plus x cancelled with each other. You're having 4 plus x squared. Then for bx plus c also the same. For this particular bracket or fraction, you need to multiply it with this whole thing. So 4 plus x squared and 4 plus x squared will be simplified, and therefore you're having 1 plus x. Okay, so after I get rid of the denominator already, then what am I going to do now is I try to make some, I have to substitute a value so that maybe the sum of the a or b or c disappear when I do the calculation. Okay, so as an example, I usually will take the linear factor first. So you're having the 1 plus x here, right? So you assume or imagine 1 plus x, you let it equals to 0, so x equals to -1. I want to substitute x equals to -1 into the whole equation because I know that if I substitute -1 here, this bracket becomes 0, b and c will disappear, and I can get the a very easily. Right? Okay, substitute x equals to -1 inside the whole equation here. -7, okay, minus 2, then minus 6, equals to -1 square is a 1, plus 4 is a 5. So you're having 5a. Substitute -1 here, at 1 plus x, you'll get a 0. So everything here becomes 0. When I try to simplify this part, I will be having -15 equals to 5a, and therefore my a is -3. So we are done for the a. Then let's think about the second value to substitute so that I can get some other constant term easily. Okay, so the second part that second value that I try to consider is this one. Okay, so maybe I try to make x equals to 0, because if I try to make the x equals to 0 here, b will disappear. Then left only c and a. And since you already find the a just now, right? So later you can find out the c very easily. Therefore, the second value that I want to put is x equals to 0. When I substitute x equals to 0, left-hand side is -6. Okay, 0 plus 4 is 4, 4 times a. So you're having a is -3, then with a 4. Then plus b times 0, you get a 0. You left a c. Then 1 plus 0, you get a 1. And again, you can see that very easily also you will get the value for the c. C should be equals to 6. Okay, we successfully found the value for a and c already. Now let's try out the last one to find the value of the b. Then we will see that it is impossible for me to make the a disappear, because when you're having any quadratic factor here, it is impossible become 0. Alright. Therefore, the last value, what can we consider is you can use any value that you never used before. So like just now, I'm using -1 and 0, right? For this part, I cannot use -1 and 0 anymore. So you can choose any value that you feel is convenient for you. Usually for me, I will choose the easiest one, which is the 1. Substitute the 1 into the whole equation here. I will be having -7, then plus 2, then minus 6 on the left-hand side, right? Substitute 1, you're having 5 times a. So 5 times a is -3 times 5. Then what else do I have? bx plus c. Okay, b is a b, right? I don't know what's the value for b, so I just copy it. X is a 1. Then c, just now you get a c is a 6. Then 1 plus 1 is a 2. Then try to simplify everything. By right, you'll be having -11 on the left. Okay, I think it is not clear enough, right? So I put it at the bottom. Can I just shift it? What should I do here? Oh, I know already. Maybe I should shift it a little bit to the left so that I can show everything in one line. Okay. Right. So now I let x equals to 1. Left hand side I have -7 plus 2 minus 6. Then a is -3. 4 plus 1 square is a 5. Then I'm having a b plus c, which is a 6. Then 1 plus 1 is a 2. From here, I want to simplify the equation and try to get the b. I'm having -11 equals to -15, then plus 2 times of b plus 6. Alright, so continue to solve it. By right, you will be getting b equals to -4. Alright, so you already successfully get the value for a, b, and c. Then usually for me, I would strongly suggest you to rewrite your partial fraction again. I'm having -7x squared plus 2x minus 6 over 1 plus x, then 4 plus x squared. It is equals to -3 over 1 plus x, then plus bx plus c. Because b is a negative, I put it at the back. So I'm having 6 minus 4x over 4 plus x squared. And this is basically the partial fraction that I get for the function here. Then let's continue to next part, part B. Hence, find the exact value of this integration. They give us the word hence, that means that it will be easier for you to use your result in the first part to apply integration here. Alright, so usually the style is like this. In part A, when you try to do something or prove something or solve for something, you very likely you need to apply in the next part. Therefore, you see the word hence here. Okay, I want to find out the exact value of integrate 0 to fx. Give your answer in terms of like something like this, and a and b are constant. Alright, so let's start with the integration. I'm not going to write out the function fx anymore. I straight away write out the partial fraction that I get earlier. So for the partial fraction that we get earlier, right, it should be negative 3 over 1 plus x, then plus 6 minus 4x divided by 4 plus x squared. Okay, then now let's have a look and do a little bit of analysis about the integration. For this part, the integration is not a big problem. It is basically the formula for integrating 1 over ax plus b. Alright, then our problem is this part. Okay, so for this part, if you have a look here, basically you cannot integrate directly. You might need to do something for the integration before you can integrate it. Maybe what I can do now is I try to separate the fraction and see whether is it easier for us to integrate or not. So I'm having the 6 over, then I put x squared in front. Okay, then I'm having minus 4x, then I'm having also x squared in front. Alright, so if I try to double check all this again, yeah, this one is the integration of 1 over ax plus b. This one is the integration of 1 over x squared plus 1 square, or x squared plus a square. Then this one, if you try to figure out the relationship, it will be the f prime x on top over fx at the bottom. Okay, so when you want to use any integration technique to apply to carry on the integration, you actually need to have a little bit of idea or the technique that is in our syllabus. Then from there, you slowly figure out what is the pattern that match every single method or maybe every single formula. Alright, so for this question, we are having a few important integration formula that we need to use. The first one is this one, where it is related to 1 over ax plus b. So when you want to integrate the linear function, but it is at the bottom part 1 over ax plus b, basically you have ln ax plus b divided by the differentiation of ax plus b, you get an a, right? Then plus c. So that's a formula that we can apply here. Alright, then after that, for the second part is this one. For this one, you can see that it is 1 over x squared plus a squared. How we actually integrate 1 over x squared plus a squared? Do you still remember it? Okay. And if you just in case if you forget, right? Actually, they are also provided here. But for me personally, I always suggest students, if you can, you try to memorize some basic integration technique. Then at least you know, right, what kind of technique that you can apply. Alright, okay, so let's have a look here. Basically it's this one, integration 1 over x squared plus a squared. You will get this one, 1 over a tangent inverse x over a. Okay, so go back to our example here. You should know that for the integration of 1 over x squared plus a squared, it is 1 over a tangent inverse x over a plus c. Oops, so sorry. Plus c. Okay, then after that, the third part is this one. When you differentiate the x squared, right, you should be having 2x, and you can see that we are having part of the 2x on numerator. And this belongs to the pattern of f prime x over fx. When you integrate f prime x over fx, what do I have? I'll be having ln fx. Then plus c. Okay, and again, for the integration part, which formula or which technique I should use, basically you have to practice a lot so that you're able to identify the certain pattern and also try to match it with the correct formula for integration. Alright, so you have to observe the pattern. Therefore, all the technique is important because you need to know what kind of pattern match to what kind of technique. Alright, so I show you the details here already. We are having 3 terms here, so for all the 3 integration here, we are using different formula. Right, so let us start. Okay, for the first term, I want to integrate -3 and then 1 plus x. -3 is a constant, therefore I just copy it. Bring the 1 plus x go up, become ln, then 1 plus x. Then differentiate 1 plus x, you get a 1, right? So I have to divide the whole expression here with a 1. So I didn't write it out because anything divided by 1 still the same, right? No difference. And now I have to put in the limit 2 and 0. So that's the first term. First term, apply first formula. So this is what we get. Then let's have a look for the second term. For the second term here, I want to make it as a 6. Then integrate 1 over x squared plus 2 squared. 4 can be written as 2 squared because in my pattern here, the general formula is 1 over x squared plus a squared. So my a here is a 2. Alright, so I will integrate it in the next step. Then for the third term here, I will write it become -2. Then I'm having 2x over x squared plus 1. Maybe you ask, why do I need to factorize out the 2 as a constant and keep the 2x inside? It is because of, if let's say my function fx is x squared plus 1, then if I want to apply f prime x over fx pattern, my f prime x is 2x. I must have 2x as a numerator, only I can apply this formula, right? Okay? Therefore, I keep the 2x and the extra 2, I will pull it out as a constant. Alright, so this term basically is f prime x over fx pattern, and we are going to apply it by using this formula. Integrate by using the formula here, okay? Right, so let's continue for the rest. Okay, first term, you substitute the 2 inside the expression. 1 plus 2 is a 3. Then minus -3. 1 plus 0 is a 1. So that's what I have for the first term. Second term, I try to keep the 6 and I integrate 1 over 8 x squared plus a squared. I will be having 1 over 8, which is 1 over 2. 6, I just keep it on top, so I will be having 6 over 2. Then tangent inverse, then x over 2. And because a is a 2, right? And now you have to substitute in the value 2 and also 0. I forget to put all the limit here, yeah? This one is also 2 and 0. Then this is also 2 and 0. Then for the third part, -2 is a constant. You can just copy it if you want. Then integrate f prime x over fx pattern, you have ln x. So I'm having ln x squared plus 1 with the limit 2 and also 0. And now I can further simplify all the terms here. Ln 1 is a 0. Okay? For the first time, I'm having -3 ln 3. Then minus 0 lah, or plus 0 also can. For this part, I'm having 3. Substitute the 2 inside, I will be having tangent inverse 1. Okay? Then substitute 0. Tangent inverse 0 is a 0, so I no need to write anything. Or if you want, you can write -0 minus 0. For the third part here, I will be having -2. Okay, then ln 2 square is a 4. 4 plus 1 is a 5. Then minus, substitute 0 inside, you'll be having ln 1 again. Okay, then after I apply integration and substitute all the limit, then I try to simplify it slowly. -3 ln 3. If you try to have a look for the equation here, right, basically we're having a pi minus ln b, which means that later you have to group all the ln b together. What I do now is I try to move back the 3 as a power, but the negative I still keep it in front. So 3 power 3, I'm having 27. it becomes negative 27. Tangent inverse 1 will give you pi over 4, which is 45 degrees. And multiply with 3, you're having 3 pi over 4. Then minus 0 means nothing really, no? Then let's have a look for this one. Negative 2 multiply with ln 5 minus ln 1. Okay, for this particular part, I want to use the idea where ln b minus ln a is equals to ln b over a. Yeah, now you're having ln 5 minus ln 1. So what will you get? You'll get ln 5 over 1, which is still a ln 5. Ln 5 multiplied with a 2, so you're having negative 2 ln 5. Alright, then if I try to have a look for the diagram, for the final answer again, the request of the question again, they want a pi minus ln b. A pi is there already. A pi is there, so I will put it in front where it is equals to 3 over 4 pi. Then they said they want to have minus ln b, right? What I do is like I try to factorize out the negative. I will be having ln 27, then plus 2, I bring it back, become 5 squared, which is a 25. So ln 27 plus 25. Okay, then what else do we have next? We try to combine the ln together again. Okay, then for this one, I'm using ln A plus ln B equals to ln A multiplied with B. Same thing happened for this part, ln 27 plus ln 25. We are taking 27 multiplied with 25. Let's see what we get. You are having 675. Oh, the answer is not correct. Let us check. Where's the careless mistake that we did? Okay, I realized a big careless mistake early, very early part here. So you can see that our denominator is 4 plus x squared, right? So here should be also x squared plus 4. This one should be also x squared plus 4. Integrate, you also get x squared plus 4. And the value here will be different. But I'm having x squared plus 4. Then for this part, I will be having ln 2 squared is a 4. So 4 plus 4 is 8. Then substitute a 0 inside, you'll be having minus ln 4. Then next step, ln 8 minus ln 4. So 8 divided by 4, you should get a 2. Okay, then 2, I bring it back as the power. By right, I should be having 2 squared, which is a 4. Then I think this is the correct answer. 27 times 4, you have 108. Yeah, so I'm sorry for the careless mistake made just now. Alright, so when you're watching the video, right, if you realize that, hey, I did a careless mistake or what, maybe you can put it at the comment part so that I can double check again and clarify it. Alright, it's quite common that I do careless mistakes somewhere when I try to discuss the question. Alright, so the careless mistake just now is this part. It should be x squared plus 4, not x squared plus 1. Alright, okay, so you double check the step. So by right, this is the answer. Then we double check again, is it fulfill the requirement of the question? So they're asking for a pi minus ln b. So a pi minus ln b. So very likely this is the correct answer for this question. Alright, so this is how we solve question. Alright, so let's discuss the very last question for this part. Okay, question 11. They want you to find the exact value, highlight the keyword exact, for this integration. Okay, when we have a look for this integration, right, you will realize that basically you are having two function here. One is x squared multiplied with cos 1 over 3x. It is actually a product of two expressions or two terms here, right? X squared is first one, then cos x over 3 is the second one. It is a product of two functions. When you're having the product of two functions and you want to integrate them, by right, you should be having or you should be using the integration by part. Okay, what's the integration by part formula? Alright, it is provided in the formula booklet basically. If you scroll down here, this is what provided in the formula booklet. And usually for me, right, I will want to make it simple because the dx and dx here seems like it's redundant, yeah. So I will just cancel them. And it become a simple version of the equation where it is uv equals to, integrate u dv equals to uv minus v du. And this part, like what I told my student, it is actually the question. Then this part is the solution. Alright. And if you have a look for the question here, your question need to divide it into two parts also. I need to know which part is the u and which part is the integration for dv. Okay, so let's go back to our discussion in the past here. Okay, integration by part, like what I told you, I'm having integrate u dv equals to uv minus integration of v du. Okay, so for the question part here, I need to decide which part of my question is u and which part of my question is dv. So there's a rule for us to decide it, right? Okay, we decide all the rule here by using the rule, okay, which is LIAT, like ILATE, or you can see in some book they will put it as LIATE, also can. Either ILATE, ILATE, or LIAT, LIAT also can, right? Then you should know what's the meaning for the I. The I here means the inverse function, or inverse trigo. L here means the logarithmic function, such as ln, log, and etc. Inverse trigo in our syllabus only got one, which is the tangent inverse basically. Alright. Then for A is algebra. All the terms in polynomial like x squared, then the number 3, all these are algebra. Then T means trigo, such as sine, cos, tangent, everything. And also the E will be the exponential, such as e power 2x, okay, or maybe e power negative 4x and so on. Alright, when we group our function into these few types of group, yeah, the pattern, right, you need to know that the higher group will be the u, the lower group will be the integration of dv. Yeah, so basically this is what we are using. Alright, so all the rules here you need to remember, yeah. Okay, the higher group will be the u, the lower group will be the dv. So let's have a look for the x squared. The x squared belongs to algebra, and the cos belongs to trigo. You can see that a is higher than the t, right? A is higher than the t. Therefore, what does it mean is you are having the u, which is equals to x squared. Because they say the higher group is the u, so u equals to x squared, right? Then, what is the lower group? The lower group is cos 1 over 3x, right? So the integration of dv will be equals to the integration of cos 1 over 3x dx. You copy down the rest of the expression. Alright, so once you know which one is the u and which group is integration of dv already, for u equals to x squared, you try to differentiate it. For this part, you try to integrate it. So differentiate u. I will be having du over dx, which is equals to 2x. Okay? Then for this one, integrate dv, you will get v. Integrate cos, I will get sine. Copy back the angle, integrate the, divided by the differentiation of the angle, which is 1 over 3. And I should be getting 3 sine x over 3. And you can see that when I apply the integration by part, right, this part I didn't put any plus c yet after the integration. It is because of it is not my main step yet. I will only put the plus d plus c after I complete the integration in my main step. Alright, so I just keep it as this without this plus c. Alright, so now I already successfully differentiate and integrate for each part. Then I will start my integration. My question is integrate from 0 to pi x squared, then cos power 1 over 3x dx. Okay, according to the formula, it should be u times v. What is your u? U is x squared. What is your v? V is this one, 3 sine x over 3. And this is a definite integral, therefore you have to put in the limit pi and also 0. Okay, then according to the formula, you're having minus, so you copy the minus. You have the integration sign, you just put it as integration sign. What is the v here? V, you already got it just now, which is 3 sine x over 3. And what is the du? Du you can get it from here, where if you further simplify, you will be having du equals to 2x dx. So I have to put 2x dx at the back. Alright, so I have settled the integration by part here. Then let's continue and see how can we get the final answer. Substitute pi inside, you'll be having pi squared times 3, then sine pi over 3. Substitute 0 inside, you'll get the whole thing is equals to 0. If you have a look for this particular part here, you realize that you'll be having negative 6. I usually prefer to take out the constant, but inside I still see x multiplied with x over 3. Okay, so the front part here should be no problem. You try to simplify, you'll be having 3 pi square sine pi over 3. You'll get sec 3 over 2, right? So I'll be having 3 sec 3 over 2 with pi square. Minus 0, you don't need to write anything. Then let's have a look for this one. Can I integrate this particular part directly? If you try to visualize it again, yeah, this one basically is the x multiplied with another trigo. You are having algebra multiplied with another trigo, which is very similar to what we have on top, algebra multiplied with trigo, right? So that means what? That means you have to apply integration by part for the second time for this particular term. Okay, all right. So what should I do now is maybe I put it in some color, yeah, so that you're aware of it. I can take purple color. Okay, now let's have a look for this part. We want to apply integration by part also, so I put it here. What is the A? What is the x? X is algebra. What is the sine? Sine is trigo. So again, algebra is higher, right? So you let u equals to x. Then integrate dv equals to the integration of sine pi over 3 dx. Then just like what we did just now, you try to differentiate it and you try to integrate this. Differentiate u, you have du over dx equals to 1. Then when you want to integrate this, what do you have? Integrate 1 dv, you'll get a v. Integrate sine, you have negative cos x over 3. Divided by the differentiation of x over 3, you're having 1 over 3. Again, I ignore the plus c here. So you'll be having v is negative 3, then cos x over 3. Okay? And now, what should I do now is, I try to apply integration by part for the second time at this particular expression here. The limit is still the same, yeah, 0 until pi. Okay, so you can see that I try to take negative 6, put a big bracket. Okay, put in the formula. uv. U is the x. V is this one. Negative 3 cos x over 3. Multiply with the x, I rewrite it again, yeah? So you should be having negative 3x, then cos x over 3. And you need to put in the limit of yeah. Okay, so I'm having negative 3x cos x over 3 for uv. You need to put in the limit pi and 0, then minus integration of v du. So again, what is your v? This is your v, right? So you'll be having negative 3 cos x over 3 du. So your du dx equals to 1, therefore your du equals to dx. Then close bracket. Right, so I hope that you can see this part clearly. Yeah, this is the integration by part for second time. Okay, yeah, then now let's simplify our value here. Substitute the limit. Okay, so you have to be very careful, yeah, because when you're having all the sign, positive and negative and everything, right, you will make careless mistake very easily. So let's have a look here. Substitute the pi inside, so I'll be having negative 3 pi cos pi over 3 minus negative 3, so minus negative 3. You substitute 0 inside the x here, it becomes 0, right? So I don't need to write out so complicated, so I straight away write it as minus 0. Okay, then negative 3, you have a positive 3. Multiply with negative 6, you'll be having negative 18. 6 times 3 is 18, right? Okay, so now you have to integrate cos x over 3. You'll get 3 sine x over 3. Then substituting the limit pi and 0 as well. So maybe you ask me, how I know that integrate cos x over 3 equals to 3 sine x over 3. We did it just now. Integrate cos x over 3 equals to 3 sine x over 3. Okay? Yeah. Then again, slowly. Because this question looks very complicated, right? Okay, so just want to make sure that everything goes correctly without any careless mistake. Negative 6 times negative 3, I'm having positive 18 with the pi. And then cos pi over 3 means cos 60 degree, you'll be having half. Then for the last term here, negative 18, you just try to copy. For me, I will take out the 3 as well, yeah? So negative 18, 18 multiplied with 3. So what do you get? You will be getting 54. Then I only substitute pi inside here, you'll be having sine pi over 3 minus sine 0 is a 0. Then again, further simplify one more time. 18 divided by 2, you have a 9. Okay, then negative 54. What do I have for the value of sine? Pi over 3. It is actually sec 3 over 2. Okay, then I think you can still further simplify some more. So 3 sec 3 over 2 pi square plus 9 pi. 54 divided by 2, you'll be having 27 with sec 3 here. Alright, so should be our answer because in the question they request for exact value. So you shouldn't change it into any decimal number, but you have to keep it in this form. Alright, so this is how we solve the question 11. And this is the end of the video. Thank you very much for watching the video.